Welcome back, Calcsters. Today, here in just a few minutes, we're going to talk a little bit. What's an autobiography?
Self-written biography.
Okay, I have thought about writing one. This is a lie, just so you know. I'm just setting up a comment I get to make later. I've thought about it, and what makes a good autobiography versus a bad one? Obviously, the story that one lives certainly has something to do with it. I am the main character in my autobiography, just for the record. The title. Titles of books are important, right? Okay, we're going to think about, and keep it in the back of your head, if you had to title your own autobiography, what would it be? Okay, all right. So, with that, I know that that seems like completely out there, and it kind of is, but it's purely in setup for a dumb joke that's coming about 15 minutes from now. So, here we go. In 2.4, we are going to get real complex with stuff. Not complex as in difficult, but we're going to talk about the complex numbers. Okay, you will never see me write this again, and that's probably a lie, but there is an accepted shorthand. You guys know the real number shorthand, I think. Blackboard R, the two lines, right? This one. Z is the integers. What's Q? I didn't write it, but you don't have to write it here. What's this one? Quotients, and quotients come from division, and division is a fraction. These are the fractions or rational numbers. Okay, there's another one. The complex numbers, they do get their own format. Do you guys remember the symbol for this? It's a Blackboard C. Here it is. It's a C, and then I just draw a vertical bar.
It's a blackboard C.
So the blackboard, when you hear that in front of something, it's with that double bar.
Interesting.
Yep, because math forever has used really fancy notation, and the only place you would ever see this written is on a blackboard in a math classroom. I made that up, but the etymology seems realistic. Cool. Yep, it's just what it's called. I don't know the etymology for sure. Okay, what do you guys know about the complex numbers? I guarantee it's more than you think you do. Do you guys remember hearing them? I think you do. If you didn't catch that, I think you do. What? Don't you guys blink at different times? Like a reptile. Okay, here we go. These things arise. Totally optional, but a little bit of motivation. We can factor and solve quadratics, right? Yeah. If I asked you to solve this one, x squared minus, and you don't have to write this down, we'll just think it out. X squared minus 4. There's two approaches to solving this. How would you do it? Somebody would add 4, and somebody would factor. Realistically, most of you would probably just add 4. I would factor. This factors, if we go that route, as x minus 2 and x plus 2. It's the difference of two squares. Or if you want a different route, you would add 4 to each side, and you get this. And then to undo our square, we do what? And when I take the square root of a number, I always include my plus or minus. And what's the square root of 4? In either situation, we're going to get x is 2 and negative 2. Like, we get the same answer. That, nothing crazy happens. Here's a much simpler looking quadratic equation that I want us to also solve. Now, it's not a difference of squares, so that's kind of out. So what should I do? I'm going to subtract 1. Now, to solve it, I'm going to do what? I'm going to take square root out of the left, and somebody knows this answer, but I don't necessarily just want you to shout out I. Does everybody know it's I? Okay, if I hadn't done that, and maybe I shouldn't have because I thought that everybody had it locked in and ready to just answer it, and it wasn't going to work. If you don't remember why it's I or that it's I, what do you think the two things that people suggest are? Somebody's inevitably going to say, oh, that's what number? Is it reasonable that somebody says 1? Like they're goofed up, they say 1, right? And then I say, well, what's 1 times 1? 1. And that's not negative 1, so that doesn't work. So then naturally, people will go, oh, okay, you got me good, Holly. It's not 1, it's negative 1 is the next option that people go with. And they feel proud and good, they should. So what's negative 1 times negative 1? 1. Which is still not this, which means we need something else. I wish the language had been different. When we talk about real numbers, do numbers actually exist?
No.
Kind of a philosophical question. Okay, right? Like legitimately, quantity as a concept exists, I think, outside of humans. Because if you give a dog two options of a bowl with 3 pieces of food or like overflowing bowl, dogs I don't think can count. I don't know that, but they have an idea of quantity still. Which food is the dog going to go after, the 3-piece or the full bowl? Like, yeah, dogs aren't dumb. They have an idea of quantity, which means it's not just a human object, right? Like, they must be able to. If I want to know where do I go hunt, it's, well, where do I see more animals? And the idea of more is a number, kind of. Now, we make up as human beings the one that we write down as a 1. Like I say, without humans, the existence of a single object does already, it happens. Whether we're there to call it 1 or not, that does exist. Now, in the same sense, just as real as the number 1 is, the square root of -1, it's not a real number. We call it complex, but there's a worse word for it. Do you guys remember the word? Imaginary is the word that we're going to use. Okay, we do not think about real and imaginary in the context of like reality. If you agree that 2 is a number that exists somewhere in the universe, whether we're here or not, then I is a number in the exact same sense. It is a terrible choice for imaginary. When you go to higher level math, where these show up, and realistically, I think the complex numbers are much more meaningful in the grand scheme of the universe, that you cannot do any part of the standard model of physics that like really dictates what happens in the universe without complex numbers. You cannot understand how electricity moves without complex numbers. Like, these things are way more applicable in like higher level settings, but we call them imaginary and people act like they just don't exist. Nope, it's just a name. Just like even, like there's no such thing as being an even number. What does that even mean? It just means it's a factor of 2, or 2 is a factor of it, so forth and so on. They exist. We're going to use I. I hate the term imaginary. We should have used quaternion numbers is what it should have been. Quaternion, and I know that feels odd. If you study math, you'll see why eventually. Poor choice. That's it. Okay. With that said, let's dive in. So, today we get to start by talking about the more general class of these complex numbers. So here we go. I'm just going to write this, and that's our shorthand for what? The complex numbers, and it's just kind of redundant. So we're just going to get a definition for this real quick. And it's weird to have a definition because it's not really there. But if we let A and B be just any 2 numbers that are real, and again, they're just language. This is every number that you've ever seen, with the exception of I, is real. Then, the complex numbers are of the form, rather. And every complex number ever will look like this. A plus BI. That's it. Now, did you guys use the complex numbers before Algebra 2? And Davian, have you ever seen this?
Learning right now.
Like, you were learning it in Tucson, or you're learning it right now physically here?
Physically online. I have all my classes for Algebra 2, and I'm learning that right now.
Okay. Please come to me if there's discrepancies in the way it's talked about. I guarantee we're doing the same stuff. It might just look a little different. Interesting. You're doing 2. Good. Bad. I don't know. All right. Every number before you've seen I, you actually dealt with these your whole life. Like, give me a number that you think isn't complex. 1. It is complex. What would B have to equal if I wanted this to be 1 plus nothing? If I do 1 plus 0i, is that still just 1? And if I can write it in this form with a 1 plus 0i, even though 1 does not feel like a complex number, it really is, right? It's just like how there's a 1 written on every x to the first power. We don't write the 1. If we don't need to write it, like if I just want the number 1, I can just write 1. But I could really and truly, and should, but we don't, because thank goodness we don't, I could write 1 plus 0i, and it's the same thing. Still complex. Now, as we deal with this, every number has this form. Every number that you've ever dealt with. There are 2 distinct parts. This part is what we're most used to. This is our real part. Now, this is a little strange in how we talk about it, but this whole piece then, and I hate the language, but not my choice, this, if not the real part, must be the what part? Unreal. I'm okay with unreal more than the other, but nobody will ever say that. Maybe we should. Don't misinterpret what I'm saying. Nobody does. You could be the agent of change. All right. A little motivation. Check it out. If we let b equal 0, just kidding, not, there it is, b equals 0, we get the real numbers. Pick any value of a that you've ever looked at and let b be 0, so you're adding 0i, nothing. Like, that's it. That's all the real numbers. Now, on the flip side of this, if a is 0, do we have any real part of our number? No. So in the case that a is equal to 0, we get, and these are pretty seldom, but we're going to define it just right here. It is a pure imaginary number. Okay. Boom. Now, there is one little thing that we should probably write down. I'm going to let you elect whether you write it, because I think the second I put it, it'll be ridiculously obvious. I'm going to make a quick claim, and I want you to help me see if we can finish this. Now, this is just a nice property. Can real numbers be equal to real numbers? Like, is 2 equal to 4 over 2 still? Like, we have different ways to write it, right? But they're the same quantity. I'm going to make one claim, and I just want you guys to see if we can finish it. If a plus bi hypothetically is equal to another complex number that we could say is c plus di, then I think that we know some things have to be equal. And I think your gut feeling is probably going to be perfect. Let's see here. I'm going to call in a random person. I don't know how many people are in here today. 11 now? Number 7, are you here?
Yes.
What is A equal to, Dolan?
C.
Anybody agree with that, and that's your gut instinct? If A plus BI equals C plus DI, then the real part here should probably equal the real part here. Believable? Reasonable?
Yeah.
Okay, yeah, it's there. Number 10, are you here? Okay, number 11, are you here?
Yeah.
Okay, what else do you think? Are you okay with A equals C, the real equals real? And I want you to go way out on a limb here. What do you think I'm going to say B must be equal to? D. Also seem reasonable? The equality of complex numbers also exists. Maybe we have different ways to write them with fractions and stuff. This is true. Okay, the fact that we can use equals is pretty important. Now, when we look at the complex numbers and I and stuff, because we haven't referenced it yet, we're going to spend just a brief minute here. So, little subsection, we got our equality statement. Let's go ahead and define our imaginary unit, or the imaginary unit. We're going to get through this part, and then we'll do the fruit one, okay? Or we could save it for tomorrow, but we'll probably just get through it today. Okay, the imaginary unit. When we do normal math that you guys have learned, and I don't want to say normal math, when we do, I don't even want to call it basic, the math that you have seen, we'll just call it that. You've been lied to your whole career, right? Up until Algebra 2, you were always told that square root of negative 1 doesn't exist. I assume you were lied to over and over and over about that, if anybody ever asked about it. When we define this, it is simply defined as the letter I, and it is exactly equal to the square root of negative 1. Okay, where this shows up is all over the place. If you've ever used a quadratic formula and it doesn't work because you never get across the x-axis, but we know that every polynomial has some roots of some sort, well, then there's a question of where do they exist then if they don't cross the x-axis, because they're the same things. And they do cross the x-axis, but in the imaginary dimension, or this complex dimension that we just don't normally work with. We normally work x and y. There's no I anywhere on there. Okay, when we're looking at this, I want us to do a little bit of scratch work here. It can be in your margin. What did I say is one of the two most important things about an autobiography? The title. Any ideas for good names of autobiography? So check it out. This is not as good of a joke as it seems like it might have been built up to be, so give me some credit. I want us to talk about powers of I. That's what I would call my autobiography, by the way. It feels kind of deep. It's not really, but I don't know. The powers of I. Kyle Holloway. Cool. I want us to do some thinking. We're going to do some scratch work. And we're going to do a circle. And I know that sounds crazy, and you're like, what do you mean we're going to do a circle? We're going to do a circle. This first one's going to be silly. I want you to scratch work. Off on the side, I'm going to put mine in this pink grass box. Wonderful. Scratch work is pink grass box today. This is going to feel silly. What's I to the 1? Everybody okay with that? I'm going to work this direction. We're going to make a circle here in a minute. I squared.
Negative I?
It's a good thought, but let's think it out. Everybody, like, you should, like, we'll put all this together, but I want you to help me figure it out first. You can do some scratch work off to the side. Yes, absolutely, because you'll need some. If I wanted to do I squared, do we agree that that's I times I? And what is I?
Square root of -1.
So if I did this, it's just square root of -1, and I guess I could probably just do square root of -1 squared. Are you guys okay with that? Okay? So if I were to do this, what would happen with it? They're gone. Can we all agree that I squared is -1? Now, if I wanted I cubed, and this is where it gets really easy, all I have to do to go from I to I squared was multiply by I again, right? To get from I squared to I cubed, what do you think I should multiply by again? I. What's -1 times I if we do that? So I cubed is apparently -I. Have I lost anybody yet? Not -1. Yeah. To go from I to I squared, do you agree that I just go I times I? And I just multiply by I one more. To get from I squared to I cubed, I just take this and I multiply it by I one more time. Does that feel okay? If I want to go from x to x squared, what do I multiply it by? Okay, what if I want to go from x squared to x cubed? What do I multiply by? What if instead of saying x, I said, what if I want to go from I squared to I cubed? What do I multiply it by?
But how is it negative? Oh.
Is it here that the issue is?
It's just, I thought I was square root of and then if you
So there's the issue. I is equal to the square root of -1. And I just wrote it as I here for now, but I'm okay with this. If we multiplied this again by an I, do you agree it's the same as just saying it's squared? And what's root -1 squared?
-1.
Okay, so now we're at I squared, right? Multiply once more to get to I cubed. And if I already have the value of I squared, I can just do it once more. What's -1 times I? Yep, and that's how we got there. Okay. All right, one more step. Last one, I to the 4th. I'm just going to take this value and I'm going to multiply it by I, right? So I get -I squared. But I realize that I squared we've already claimed was -1. So I have a -1. And I get a 1. Now, here's where we get wonky. If we go one more, so hypothetically, I'm not going to write the 5th power, but if we wanted to, do you agree I would just take this and multiply it by I one more time?
Yeah.
And when I do that, what do I get? I again. We form a nice, lovely circle. Now, I will never ask you guys about this specific language, but I'm going to show you some math language. What you are doing right now is we're on just the very brink of being able to talk about something called modular arithmetic. Okay, that sounds really fancy, right? It doesn't have to be. Clock arithmetic is the synonym. Check it out. If I want to go 6 hours plus after, let's say, 10 a.m., if we don't use military time, 6 hours plus past 10 a.m., I think it's 4 p.m., and we just claimed that 10 plus 6 is 4. Why? It resets at 12. Now, here's what we need to think about. Do we agree that it is really 14?
Yeah.
Or is that 14, 16?
1600.
Okay, there we go. So 10 plus 6 is 16, right? Now, when we put a clock on the wall, we only use how many units?
12.
So divided by 12, it goes in ones. What's the remainder? So 4. So there's how it works, right? You just, essentially, if you've never been aware of it, you're just using remainders without actually thinking division. When we do this, it turns out that this can be really helpful on nice in specific situations. I would take this picture here, and whether you like the circle or not, I make sure you have this. If it's already in your notes, that nice powers of I to the 1 equals I, and then we go to I squared is negative 1, I cubed is negative I. I'll make that look like it does. Kind of hate it, but I'm not going to change it. I to the 4th is 1, thank you. And then we're back here. Okay, it turns out that we can use that idea of clockwork, and it might not have made sense the first time, to get really easy values of this. If I want, and I do want, to evaluate or to simplify the following. I want to know what is I to the 231st power. Now, we could do 231 steps and see where we wind up. So, like, here's my first step. 2, 3, 4, 5, 6, 7, 8, 9. I'm not going to count all the way up to 250, right? Like, nobody has time for that. But here's what I'm going to suggest. How many steps go until we repeat? 4. Follow-up question. I promise it's related. If you divide something by 4, what are the choices of your remainder? Could it be 0? It goes in perfectly if it's 0, right? So your remainder could be 0 or 1 or 2 or 3. Right? Do we all agree with that? Remainder couldn't be 4 because if you had 4 left, you would just go once more, and that's a remainder of 0. Everybody okay with there's only 4 options for a remainder of 4? Yep. Or division by 4. And we also agree simultaneously there's only 4 steps here. Yep. So let's do something. I want to take this number and make it one of these because I know it's going to be one of them. All I need to know is that this is like I to the 4th some number of times, which just does a full circle. I just need to know how much is left over. With that, I'm going to do 231, and I want to know how many times does it go into 4? 4 goes into 23 how many times? So 5, we get a 20. I subtract it, I get a 31. 4 goes into 31 how many times? 7? Okay, I'm cool with that. Sorry, I don't know why it didn't sound right in my head. What's a remainder?
3.
Everybody okay with dividing by 4 to get a remainder of 3? Everybody agree that there are 4 steps here, and whether it's perfectly clear or not, there's a link to cutting it into fourths. I to the 231 is hard, for sure. Is I to the 3 hard? No, because what's I cubed?
Negative I.
Check it out. I to the 231 is negative I. You are doing modular arithmetic, and specifically we're doing division mod 4 is how you would call that. Okay. There's very few situations where we care about necessarily doing the big ones, but if we ever do encounter something I to a giant power, it's nice to have. Yes, ma'am?
If you divide by 4, why is it to 3?
Because, great question. I'm going to make a note here just to add to it. The remainder, when dividing by 4, and it's 4 because we're working and there's 4 different powers of I that show up, and then we just start repeating. This is the remainder. Yep, every single time. Abaju, was that your question also?
Yes.
Awesome. Great question. Cool. All right. Should we get wonky with it? All right.
I remember last year when we did this, I just divided them by 4, and then if it didn't go perfectly, I divide by 3. If it didn't go perfectly, like I go down, and then whatever number I ended on, like that's how many times. Like we didn't have a circle, but it was like steps.
And you are doing the same thing, but we're doing it much more efficiently. Yep, you're doing the same thing. Because you, like, without expanding on that too much, this is faster. Just divide by 4 right off the bat. If your remainder is a 1, it's I. If your remainder is a 2, it's negative 1. If it's a 3, the answer is negative I. If the remainder is 0, or 4 in this case, then it's 1. Okay, cool. All right, so when we're looking at complex numbers, obviously we're going to see the quadratic formula, I would assume, later in this chapter. But let's start doing some basic arithmetic. So we have a nice definition of the imaginary unit. Cool. We're going to just say arithmetic, or, yep, I'm okay with calling it arithmetic. Arithmetic in the complex numbers, which just means we're in C. Did you guys add complex numbers last year, do you recall? Okay. Even if you don't remember doing it, and legitimately if you didn't do it, it's going to be exactly what you want to happen. So here we go. We're not even going to talk about like defining it because I want to see if your guts are correct. All right. So here's what I want to do on this one. We're going to add and subtract. Okay. So I'm going to give you guys one to do on your own. I just want to see what you come up with first. Let's say I have two complex numbers. I'll even use different colors for them just so we can separate it. If I did 2 plus 3i plus negative 2 plus 4i. Without me giving any guidance, if you get it completely wrong, we'll just cross it out. I'm good with it. We'll know what not to do. I want you to go with your gut and tell me what happens. Any answer is a good answer unless it's just a blank. Cool. Go with your gut. I'm going to give you like 10 seconds. I said I was going to change colors and then I didn't. My bad. Addison, did you get an answer? Okay. What did you try to do confidently, I can tell?
I just added the, like, 2 and negative 2 and then right here.
So Addison added the real parts together. Anybody else do that? What's 2 plus negative 2? Okay, I'm going to write it out longer. I don't think I necessarily need it. But my parentheses didn't really do anything, right? Like I wasn't distributing or nothing. They were just there to keep my numbers straight. Can I rearrange addition? Yeah, and of course you're going to put like terms together. The real part and the real part are like. They're gone. Did you get 0 plus 7i? We're done. You're correct. It does work exactly like that. Cool. Do we need to do another one of these? Cool. So what's cooler than like subtraction's the same. What do you think the mistake people make is if I put a minus here? People forget to distribute. Pay attention, distribute it. There's a reason we use parentheses with stuff. The addition, what? The addition, weird emphasis. Okay. Well, addition and subtraction is pretty cool, but I want to do 4th and 5th grade math instead. What's next? Hey, let's multiply. Multiply in the complex numbers. Now, depending on the situation, these ones may be a little odd, depending, but let's go ahead and dig in. On our first one, and we'll do at least 2, we'll do 2 minus 4i, and we're going to multiply that bad boy by 3 plus 3i. The fact that it's an I makes it look different. Makes it look harder, makes it look scary. It's not, it doesn't, it shouldn't. The fact that it's an I is just a variable choice. If it were an X, would it be as scary looking? No, and what's the F word that I'm looking for? Not quite factor, but you're close. Foil. There's only like 3 or 4 of them, and you might not always know the exact ones, but I really want to highlight, I appreciate you guys not dropping the wrong choice. Do you want me and us all to foil this out together, or do you want to try it on your own first? Love that. Cool. I'll give you a moment. I'm going to pause it here so that Red doesn't have to watch a video and I can say the really mean thing about him. I think that Red is, from here, once we have it, would probably be to combine your like terms. And you're going to get to here. That's minus 6i, right? My bad. Minus 12i squared. Do you guys have this on your page? Did you stop here?
No.
Okay, if you did, you're not wrong yet. You're not completely right, but I wouldn't say you're wrong. What's I squared again? I'm going to make this little note. Careful, I heard 2 different answers. Is I squared negative I or negative 1? Negative 1.
Oh.
Okay, if you have it wrong in your circle, please go fix it. Okay, which means this is really 6 minus 6i minus 12 times negative 1. And I'm taking way more steps than I probably need to. What's going to happen here? So we have 6 minus 6i plus 12. And we wind up, I believe, with this lovely complex number, 18 minus 6i. And we're done. Cool. It works about like you would expect. The most common mistake that people make is leaving I squared. Here's the general rule that we're just always going to follow. I to the first power is all we ever want. I don't want I squared. I don't want an I cubed. I don't want an I to the fourth or to an I to the 964. Don't care what number it is. I only want I to the first power, which is why we took the time to give ourselves these 4 that we'll use over and over. Cool, cool? Okay. Now, there's one little spot that gets weird. It's not going to happen today in our work. It probably happened in Algebra 2 last year, and I don't know if you guys caught that it was weird. I'm debating if I want to think about it. Let me kick that around in my head for just a minute. I want you guys to do one for me here. Okay. 4 plus 5i times, do you guys know what a conjugate is? Okay, so we'll clean this up here in a second. So here are some conjugates, just so you know. If you don't recognize that language, that's okay. They show up with radicals, they show up with imaginary stuff. I want you guys to do this FOIL for me. I'm going to give you a second. We'll come back together. Now, is it going to happen every single time, or is that just a coincidence here? Every single time. Now, here's what I'm going to suggest. If it's going to happen every single time, maybe we could just save ourselves a little bit of work every single time. I know for sure that this is going to turn in, first step, to 16 minus 25i squared. After we fall out the 20i, negative 20i, is that what you guys had left? And if we have a complex number like this, we're always going to have a minus and the I squared. Every single time that we get I squared, what is I squared?
-1.
So do you guys agree that if I wanted to, I could, and you might not see the reason behind it right now, but this is 4 squared plus, well, if this would be plus 25 when I do it, right? Do you guys agree that's just plus 5 squared? And when you guys cleaned everything up in the end, did you get 16 plus 25? It equals 41. Foiling is fine. Fantastic. I can't do any more. I was trying to make every word F. Maybe, just maybe, we don't really have to foil if we get this exact situation. There's a shortcut here, and I want us to see it. On C, last one that we're going to do today, and we're going to use the last couple minutes to do our fruit thing, because I forgot about it. I'm not going to give you guys an assignment this evening, because there's a few more things I want to look at tomorrow. If I were to take A plus BI, and multiply it, and we'll define this tomorrow. This is called its conjugate, just so you know. We take A minus BI. All we change is that middle sign. What happened with all the I stuff in here when we did the previous problem? It just falls out, right? So check it out. This first number was this squared. Everybody agree that, like, we can very clearly see that happened. What's the first number here? A, and we square it. Now, I know that I'm going to get plus ABI minus ABI if I were to FOIL it, but I don't want to. And then I'm going to wind up with my very last term is minus, and I don't want you to write this, but my very last term would be minus B squared I squared. Or BI squared if you'd rather write it like this, but this is going to work nicer. And every time, what's I squared going to get replaced with? So if I have minus B squared times negative 1, it's always going to change into that plus B squared. We no longer have to FOIL if we take some number times its conjugate. And last little thing, just to demonstrate how quick these are, I want to know what is 3 minus 2i times 3 plus 2i. You get 5 seconds. Okay, it's actually 10. 1, 5. Do we all get 13?
Yes.
And if you didn't yet, it's this easy. A is 3. We're always going to add because the I squared shows up. All we have to do is 3 squared plus 2 squared. We're done. It is 13. This is a huge time saver in lots of parts of future problems. Cool, cool? Do you remember doing conjugates before?
Yeah.
With radicals. Because if I had something that was divided by 2 minus root 3, I multiplied it by 2 plus root 3 over itself. Like, that is where you've seen it. Okay, best and worst fruit is what we're going to knock out. And we're going to pause this.